everybody. We're getting ready for experiment number 4. We're going to study metallic carbonates and metallic hydroxides. And what we have here is there's sodium carbonate. It's a white solid. On all sodium compounds are soluble in water. And this is potassium carbonate. It's a white solid. It's also soluble in water. And the original name of this is soda ash. That's from, and this one is potash. That's the original name. Those are sources of the names for the elements. Okay, what I did, I measured out 2 grams of each on these pieces of paper here. And I have 10 milliliters of water in each of these. And I'm going to put the sodium carbonate into this one. And it should dissolve. It might take a little bit of time to dissolve. It should dissolve. And I'll put the potassium carbonate into this one, and it should dissolve. And is it dissolving? Yeah, it looks like it is. That's good. They're dissolving. Takes a little while to dissolve. Just let it dissolve. Yep. These are almost dissolved now, see? This one is all dissolved. These bigger pieces take a while to dissolve, but it's all right for the moment. To do the next experiment, we're going to check the pH. Remember the pH meter? Here's the pH meter again. And these should be bases. Remember the pH of pure water is 7, and so in basic solution or alkaline solution it's going to be higher than 7, and in acid it's going to be less than 7. Whoops. Second here, let me get this out. These are the electrodes of the pH meter. So let's see, let's stick it into the sodium chloride first. You see it? See what the pH is? It's about 11. It's over 11 now, right? Yep. Going up. It's still going up a little bit. It's starting to stop going up. Let's see. That's probably good enough. It's a little over 11.3, right? So it says alkaline, right? So that means the carbonate ion is a base, is what that means. Consists with water. And then we'll stick it into the other one, which has the potassium carbonate in it. It's going up again, right? What was the other one? It's about the same, right? The other one was 11.3, yeah. It's going up about the same amount, right? Everybody see that? That means the carbonate ion is a base. It's common to both of them. The only thing is different. One has potassium ion in it, and then the other has sodium ion in it. Okay, that's good enough. Okay, here's that sodium carbonate in water. It's almost completely dissolved now. There's a little piece in there. This one's completely dissolved. And I'm going to add 1 milliliter of hydrochloric acid, and watch what happens when I do this. Everybody watching? Did you see that? There was effervescence, wasn't it? Let's add it to this one over here. Yep. And you're seeing the gas being evolved, right? That's the end of part 1. Now we're ready for part 2. I'm going to add 2 milliliters of hydrochloric acid to the sodium carbonate. Now what I'm going to do is light a wooden splint and stick it in there and see if that's a good test for carbon dioxide, because I think that's the gas produced. Yep, it put the fire out, right? That's a good test for carbon dioxide. It stayed in there because it was heavy and it does not support combustion. So that's a good test. Now I'm supposed to do it with the other one, aren't I? Should we do it with the other one? You think it's going to do the same thing? I probably should. Now I'm going to light the wooden splint, stick it in there. It should put the fire out. I hope it does. Yep, it did. So that's a good test for that. Okay, now what I'm going to do is add enough hydrochloric acid to completely neutralize the carbonate. We can tell when it's neutralized because it'll stop effervescing. Just about done, isn't it? I think it is. Let's add just a little bit more. Yeah, that's good. Now I'm going to do the same thing with the potassium carbonate solution till it's all neutralized. It's just about neutralized now. Okay, it is neutralized, I think. Maybe one little bit more. Now, if you balance the equation, the one with the sodium carbonate should end up as sodium chloride solution. So this should have salt in it, salt solution, and this is potassium chloride over here. And what we'll do is we'll just let it evaporate, and then next week we'll show you what this looks like. After all the water evaporates, you should make the crystals, and then we'll be able to look at the crystals of sodium chloride and potassium chloride. Show the calcium hydroxide. Okay, now we're ready for part 3. So I have here 30 milliliters of water in this 250 milliliter beaker. I'm going to put the sodium carbonate in there, 2 grams again. It should dissolve like it did before, right? And it takes us a little second to dissolve. Now what I'm going to do is add calcium hydroxide. This is some calcium hydroxide here. You see it? It's a white solid. The common name of that is slaked lime. You can buy that at a hardware store. It's used to make mortar. Okay, that's the common name. And then this is what it looks like when you put it out. And this is 2 grams of that too. Now calcium hydroxide is not soluble in water, so we're going to get a suspension here. See that white suspension? Okay, good. Now what's actually happening there is a chemical reaction is occurring, and the sodium carbonate and the calcium hydroxide are being converted into sodium hydroxide solution and calcium carbonate. But you can't see anything happening because calcium carbonate is also a white solid and it's also insoluble in water. So the only way we can tell a reaction is occurring is by testing the products of the reaction. And what we're going to do after a few minutes, we're supposed to let this go about 5 minutes. We're going to filter these things. And then in the filtrate, the thing that goes through there should have the sodium hydroxide in it. And then the filter paper should have the calcium carbonate in it. Okay? And then we can test to see if that's true. Because you know hydroxides will neutralize acids, but they don't do anything except neutralize the acid. But carbonates, when they neutralize acid, they make CO2. So that's the way we can tell where the carbonate is. So in the beginning, the carbonate was in the solution. At the end, the carbonate will be in the solid. Everybody, this is that reaction mixture where we put sodium carbonate solution and calcium hydroxide with a solid. Now what we should have calcium carbonate in the solid state, and it should be sodium hydroxide in the solution. And the way we're going to do is test it by filtering it. And the thing that passes through the filter paper is called the filtrate. And things left behind is called the residue. You see, the filtrate is a solution, right? And that should be sodium hydroxide solution. And then what's left behind should be calcium carbonate. And how are we going to test it? Well, sodium hydroxide is a strong base and should have a higher pH. And then calcium carbonate, it should react with hydrochloric acid to make carbon dioxide and water, and we can see the effervescence when we test the filtrate. Okay, now this is the residue, and this is the filtrate. So this should have the sodium hydroxide in it, and the residue here, let me show you what it looks like. You see the white solid? That should be calcium carbonate. Okay, that should be sodium hydroxide. Sodium hydroxide is a strong base, and it should have a much higher pH than the sodium carbonate solution we started with, right? So I'm going to stick this in here and see what the pH is, and let's see if it's high. Let me rinse it off with water here just a little bit. And then let's stick it in here and see what it is. See, it's higher, isn't it? It's going up. Son of a gun. Still going up. What's it now? It's almost 13, isn't it? That's a real high pH. Much higher than it was before. It was 11 point something, wasn't it? It'll be 13 pretty soon. Still going up. There it is. It's over 13. That's very alkaline, very basic. Okay, that's probably good enough. Small beaker. Okay, ready?
Yes.
Okay, I'm going to take the residue out of this now and transfer it to a small beaker. That's probably enough. Now I'm supposed to add a little water, and it's not soluble, so it should make a suspension. And then we just add a little bit of water to it. And then I'm supposed to add a few milliliters of ConHCl. And if that's calcium carbonate, it should effervesce, right? Let's see if it does. I'm afraid to check, but let's try. Effervesce means to bubble in scientific terminology. Effervescence is bubbling. Okay, so now let me add a little bit of ConHCl and see if there's effervescence. Yes, so that means that is calcium carbonate. This is not an experiment. Shall we test to see if that's carbon dioxide? Let's do that. If it's carbon dioxide, it should put the fire out, right? Let's check it out. Let's do this. It's not an experiment, but there's nothing wrong with doing research. This is research. Yes, it did put the fire out, and that's a good indication it's carbon dioxide. Carbonate and calcium hydroxide into sodium hydroxide and calcium carbonate. And the reason why that reaction went was that the calcium carbonate's more insoluble than the calcium hydroxide is. Okay, still effervescing. Okay, that's good enough. Hello everybody, we're going to do part 4 now. And what we have here is a gas generating bottle, and I put 5 antacid tablets. Those are calcium carbonate. So we're going to use this to make carbon dioxide. And you pour a liquid in. If you seal it off at the bottom, it can't come out there. The gas will come out the side. And once we get it going, I'm going to put this is the filtrate from that reaction we just saw. I can put the filtrate into this test tube. I'll put it in now so you can see it. There's the filtrate. Okay. And what I'm going to do is I'm going to put some water in here to seal off that tube. Is it sealed off yet? A little bit more. Now it's sealed off, isn't it? Yeah, it is sealed off. Then we're going to add 10 milliliters of hydrochloric acid, and we should see the same reaction. Calcium carbonate reacts with hydrochloric acid to make CO2, and then we'll take the CO2 and bubble it through the sodium hydroxide solution. Are you ready? Is it effervescing? Yes, it's making carbon dioxide. And I'm going to bubble it through that solution there. Okay? Now what actually happens, the carbon dioxide reacts with the hydroxide ions to make bicarbonate ion, HCO3 minus ion, and that reacts with the sodium hydroxide to make carbonate. So we should be making sodium carbonate. We're reversing the process then. By putting carbon dioxide into the sodium hydroxide, we're converting it back into sodium carbonate. Well, how can we tell that? Well, the way we can tell it is we can add hydrochloric acid to it. Well, the pH should drop, and when we add hydrochloric acid, we should get effervescence. So we're going to have to let that go for a while. So let's turn it off and let it go for a while, and then we'll come back and look at it. Effervescence has stopped. You see that? So now what we should have, that should be sodium carbonate in there. And what we're going to do is I'm going to take it out and pour it into that beaker, and we're going to check the pH again. And if that's sodium carbonate, you convert the sodium hydroxide into sodium carbonate by reaction with carbon dioxide. It should have a pH that is lower than it was. That was 13 to begin with. Let's see what it is now. Let's see if it worked. If it did lower the pH. Well, I better get this out so you can see it. Yep, look, it's 11. It's 11.4. It lowered it by a lot, didn't it? It did lower it. Everybody see that? It might be around 12. We didn't get it completely done, but it is lower. It is lower. It's going up a little bit. It's almost stabilized. A little bit more than 12, but the other one was 13, so quite a bit higher pH. Now what I'm going to do, the last thing I'm supposed to do is add hydrochloric acid to this, right? How much am I supposed to add? Let's see. I'm going to add a little bit of hydrochloric acid and see if we get any effervescence. You see it? We got effervescence. You see it? So we did convert it back into carbonate. Okay, so now we're getting the carbon dioxide back out again. Okay, so we converted the hydroxide into the sodium carbonate, and that it concludes the experiment. You have to write an equation for the reaction of carbon dioxide plus sodium hydroxide makes sodium carbonate plus water, I guess, right? Sodium carbonate and water. And that should be the end of the experiment.